All right, guys, so now we need to focus more on the Stratum Purge and Trap. So this, again, is made by Teledyne Tecmar, and this is an older version of a Purge and Trap model that they used to make. They've revamped it. They made it accordingly a little bit better, but this is the system that we're using, and this is what we want to take a look at. So we can see the sparging unit up here in the very front, and we talked about the purpose of the sparging unit now. So that eventually is going to get my sample, and up front and center, I will be able to see those helium bubbles that will begin to bubble through my sample and push out the volatile organics that might be on the inside. And on the inside of this box is the trap piece that will capture those volatile organics and keep them for me until it's ready to send them into the GC system. So this is the instruction manual that's going to be loaded up into Blackboard, and I'm going to go ahead and say that this is pretty lengthy. It's actually longer than the Autosampler instruction manual, as you could probably predict, and we're looking at about 123 pages. So when you access this instruction manual, it's probably going to take a little bit to download depending on the speed and your connection. So just give it a little bit of time, but eventually, hopefully, it will load up for you on your computer. All right, as I scroll through, again, you're going to be able to kind of flip through here. I don't want you to read every single thing in the instruction manual, but I think that it's going to do us a little bit good to kind of look at maybe some of the basics that the instruction manual is going to present to you and talk about it in person. So just like the Autosampler book, in the very beginning of the instruction manual, it's going to give you some hookups. So how do you get it out of the box? How should it be plumbed? How should the helium lines be ran into the system? If you do have an auto injector, how should that auto injector be hooked up to the purge and trap concentrator? So that's what you're going to see on the front end of this manual. However, before it gets to that, it's going to give you a nice introduction. If we go through and take a look here, it says the Stratum PTC is a modern laboratory instrument designed to concentrate volatile organic compounds, known as VOCs, from samples using the purge and trap technique. They abbreviate that as P&T. The Stratum PTC uses advanced P&T technology that allows accelerated automatic processing of liquid and solid samples for the analysis by a gas chromatograph. The Stratum PTC purges VOCs from liquids or solids onto an analytical trap. The trap is then rapidly heated, and the analytes are swept with GC carrier gas onto the column for separation and detection. So a couple of things I would like to say here is that this purge and trap system can be used with solid samples as well. So if we go back and just kind of jot down maybe a few notes here, I'm going to clear that out. Liquids are really what we've been focused on this entire time, and liquids are going to be kind of the normal, routine, run-of-the-mill technique that's used with a purge and trap system. This is by far and large the most common type of processing that's done on this type of technology. However, they know that the environmental field is the one that's using the purge and trap concentrator the most. And the environmental field not only looks at air, but it also looks at water, and it also looks at dirt. So if we're measuring pesticides or herbicides or volatile organics in a water supply, how on earth can we do it from a solid sample? And a solid sample would be something like soil. So you do have the option to run solid samples on a purge and trap concentrator. It just requires a different auto injector, and it requires maybe one or two more attachments that you might need before it goes to the purge and trap concentrator. So it requires a little bit more pieces, a little bit more money, but it can be done. So you're wondering, well, why would you do it? Why couldn't you take soil and put some type of solvent to it? That solvent can maybe just be water, right? And then process the soil sample and then pour it into a vial that will be suitable for a liquid and process it as a liquid sample. And the answer is, well, you can. And the next answer is that's kind of what this other autosampler does for you. That way you don't have to do it really yourself. The autosampler can do it on its own. So it kind of automates that process a little bit more. It takes more headache out of your day, and you can focus more on other things that you have to do in a laboratory besides playing in dirt all day long, right? So you do have the option to analyze solids. And it's probably going to be a test question. You know that's coming along. Purge and Trap background, it talks a little bit about the system. It talks a little bit about what it can measure and what it can find. Again, you're more than welcome to read through the introduction, and you're probably going to see a few questions in the assignment focused on the introduction piece of the manual. I'm going to enlarge this up a little bit just so we don't have so much dead space and you maybe can see it better on your screen. But here's basically a vial or a container, and this has a solution in it. And what this is showing you is kind of what we've already explained. This solution is going to, over time, evaporate, and this is going to start forming a cloud vapor up here on top of that liquid solution. And this is what we would call the headspace. After it leaves that solution and goes into the headspace, once this reaches a certain concentration, it's going to stop, and no more sample is going to leave the solution. And we said that this is the purpose of the headspace analyzer of the GC system if we're using one. The problem is that this concentration could be so low, again, and that low concentration would give us a very low concentration in the headspace. And in order to measure this properly, we need to drive off everything in that sample and capture it and analyze it. And that's the purpose of the Purge and Trap system. They're going to go through and talk about these partial pressures, right? It's going to talk about different individual pressures, different stages, slowly capturing it off one by one by one by one. And that's basically their way of telling you blow through the straw and make bubbles. All right, that's the way that I see it. And I think if you think about it that way, I think this process makes a little better sense. Here are basically the different stages of the Purge and Trap. So this is kind of the heart of the instrument and the different steps that will happen along the analysis period. On the Purge and Trap system, what you will see, with ours at least, is this kind of LED light that's here on the front, and this light will change color. And this color represents the different stage that the Purge and Trap concentrator is in. If it goes blue, that means this is standby. It's ready for you to tell it to do something. It's ready to work. When this light turns green, it's then purge ready. When it goes cyan, it goes preheat, pre-purple, and purge, pre-purge and purge. When it goes white, it goes to dry purge and desorb ready. When it goes purple, it goes to desorb, preheat, and desorb. When it goes yellow, it goes to bake. And when it goes to red, that's death, so that's error. I don't need you to memorize the colors. I don't want you to memorize what each one of those are at different colors along the course of time. That's not the purpose of this. And, quite honestly, no one really even pays attention to it. And very few people even know that the light changes color depending on what stage it goes through. So that's not really of importance. What's of importance are the different stages that it has now listed for you. So you're seeing that this thing is a little bit more complicated than just pumping helium through and heating up a column. Because if that was the case, only 2 line items would be listed here. Purge, heat. That's it. So what they're doing is that they're kind of telling you the different stages throughout this process that every single sample will go under. So that means every sample will experience all of these stages from the color of blue through the color of red. Well, maybe not red, through yellow. And then it will reset itself and it will be ready for the next sample. And then that sample will go through all of these stages until it gets to the very end. So the purpose of this video is to talk about these stages. What really is it doing at that particular time? What are some of the settings that's going to be pretty important? Something else that I want to mention is that here in the very front of the instrument, you're seeing the sparger tube, right? This sparger tube can be replaced by you as the user and should be replaced over a course of time, but it comes in two different sizes, kind of a small and a large. And the small is a 5 milliliter chamber, and the large one is a 25 milliliter chamber. And from the time that this video is recorded, we are currently using the 25 milliliter sample sparger. We believe that what we're looking for, we need a larger amount of sample, and that larger amount of sample will be able to sparge more stuff out of it, and then our machine will be able to see that. If you go to a smaller sample size, that smaller amount of VOC that will be released, and your instrument might not be able to see that amount. So if you've got a problem with detecting various compounds that might be in your sample, then this is a way to kind of control some of that. Okay, if you use a larger sparger, that's more sample. That more sample relates to more VOC, and that larger amount of VOC will easily be seen by your instrument. The problem is that if there's too much, then it will flood the instrument and it will saturate the instrument, and you're going to see contamination problems. So you got to know a little bit about your sample before you start this process. If that's the case, then you need to use the lower sparger amount so you do not flood your instrument with all of these components that will take forever in order to get out. Here in the instruction manual, this is the side of the instrument that has been removed. Okay, so if I go back up to this instrument here, this is the way that you see it in our laboratory. This top piece can come off, and the side panel to the left can come off. If you take this side panel on the left off of the machine, it requires 4 screws, I think. That's all that it does. Just unloosen the 4 screws, take the plate off. What you will expose are the internals of the piece of equipment. This is what it would look like from the side. So there's a lot of electronic pieces in here that we don't need to worry with. But what we do want to worry with on the side panel is this piece right up here at the very top that's circled. And this circled piece, that is our trap. That is where the compounds are getting released to, and that's what's capturing them and keeping them until it's ready for the next stage. So that's why I'm kind of picking out this picture. And if you zoom in, what you're seeing here are 2 U-tubes on the internal of the machine. There's this inner one, and then there's this outer one, right? This outer one, if you've noticed, they're pointing to it. They're saying that this is actually the U-trap, and it's the trap heater, and then here is a condenser. So each one of those have their own roles, and each one of these can be replaced. The only thing that you have to do if you want to replace them, well, you don't have access to it here. The trick is that you have to take the top off, and these tubes extend on up into the top of that piece of equipment. That is where the bolts and the nuts will be, and you basically need to loosen those up, and then these columns, really that's what they are, will pop out of the machine, and you can install the new one, and then up here you would tighten those back on again, make sure there's no leaks involved, and then you can put the top cover back on. So that is how you would change those. Right now, if you just take the side panel off, you do not have access to that. So you need to go one more step, take the top cover off. So it's very difficult to get to. It's kind of time consuming. It's not very user friendly. And in the newer versions of the Purge and Trap system, they took that into consideration. And now it's much easier to get to. You do not have to take apart the entire casing of the instrument to get to that point. This picture shows you the inlet on the GC side. So once the components get trapped, they're going to get heated and they're going to get released, and those have to go into the GC system. Up at the top of the GC inlet, you're going to see basically this piece of tubing that looks like it's insulated. And on the end of that are going to be 2 what would look like typical like column nuts or injector nuts for that time. And there are two purposes for this. This one that you're seeing here toward the bottom is the carrier gas inlet. So this would be your helium line right there. Okay, and then the one here in the center that looks like it's surrounded by the insulation, this is the transfer line. So this is actually transferring your volatile organics into the GC system. It's this line here. So if you open up the top cover of your GC system and look near the inlet, you're going to see this modification at the inlet, and that is why that is present, because it's got to receive your sample from the purge and trap. It's not getting it from you, and it's not getting it from an auto injector of the GC system. It's getting it from the purge and trap system. So therefore, it has to have its own entry, and that's what that piece is for. So if you are in the laboratory and you just pop open the top cover of our GCMS and you take a look at it, that is where you're going to find that information and that piece of tubing. On the back of the purge and trap system, and as well as the Autosampler, I didn't mention this, but as well as the Autosampler, you're going to see some drain tubing on the back. That's what you're seeing, this red cord here. You know, we're pumping water through this whole system, right? I mean, we're putting liquid samples on. The liquid samples going into the sparger. It's sparging all the volatiles out, and then it's got to get rid of the water. It's got to dump it somewhere. And all of that water has to go through a drain line. So that means you need a bucket, and you need some type of reservoir that will hold all of the waste that this instrument is generating. So just keep that in mind. It's like the AA instrument if you've taken our spectroscopy class already. So that AA instrument needs to have a disposal. It needs to have liquid in, liquid out, and this machine is no different. Liquid goes in, liquid comes out, so you got to have some drain tubing, and that drain tubing has to go into some type of reservoir or bucket that you can dump at a later time. This diagram I like to show you because you need to understand that one helium tank can actually control all aspects of the system. So for instance, here's one helium tank, which they have labeled as carrier gas, but it's really helium. And that helium is getting routed through a T-junction. And this T-junction is basically split. And part of it goes through the purge and trap system, and then part of it can go into the GC system. So one tank turned on can control both. The problem, though, that some people have is that they like to maintain these two independently of each other, meaning that they don't necessarily need the purge and trap system on, but they need the GCMS on, that they're not using both of them at the same time. If that is one of your purposes, and if that's your setup that you would like, then you need some kind of cutoff valve on here. And the cutoff valve could basically be on the purge and trap side. So you can close this helium completely off, and that way the helium can go directly to the GCMS system, and the GCMS system can do its own thing without the purge and trap interfering. That also means that you can take this sucker apart while your GCMS is running, and you can do work on this side of the house, and you can maintain it, you can troubleshoot it, you can prep it, you can do whatever you want to with it, and you're not affecting a shutdown time of the GCMS or the GC system that this thing is connected to. As far as VOCs are concerned, some of these components have very low boiling points, and you want to capture those, and you want to keep them, and you don't want to lose any of them. And room temperature maybe is something that is not good enough for you and your sample prep and your sample analysis. So some of these instruments do come with basically a cryogenic box or attachment that can be coming along with your purge and trap. Think of this as like a refrigerated unit. So that means that you can lower this temperature below room temperature and keep everything cold. So that way when the volatile organics come off, they go into a cold refrigerated unit, and they will definitely stay there and they will not go anywhere. And then you can eventually heat that up to release those compounds off of the trap. We do not have one of these units. We don't play around with anything that needs to be that low. And quite honestly, we're doing everything at room temperature anyway. So if we're not very careful throughout this whole process and we're using these types of volatile organics, they're going to evaporate on us before they even get into the sample vial or the sample chamber to be analyzed. So that's why we don't have one, but that technology is out there if you need it. And that's what you're seeing in these boxes here in the instruction manual when you begin to look at it. This is just basically a refrigerated purge and trap system instead of the normal room temperature that we use in our lab. Okay? There's the instruction manual is going to go through a couple of different screenshots here that talk about, if you do have this attachment, how to set up the software and how to make the machine recognize that you can actually have this technology at your disposal. So finally, we're going to get to the heart of this video, and this is in chapter 3 of the instruction manual, and this is the instrument operations. So one of the things that I always want you to take away from the purge and trap system is the terminology. What do the terms mean? Because they're going to show up on the software, and if you don't know what the software is doing or what it's telling you that it's doing, how do you really fully understand this instrument and what's happening at different stages throughout the process? So on this next page, what you'll see are the terms that will come along with this unit. And the very first one up here is called standby. All right, so standby, if you go over to the description, this is kind of a common sense thing. The mode indicates that the system is waiting for all the temperatures and the flow rates to match your settings. So when you go in and make a method, you're putting in temperatures and you're putting in flow rates, and all of that is basically getting copied from some point or some document. The machine has to make sure that it's heated up, and it has to make sure that it's getting the flow rate that you've set. And until it equilibrates itself out, this is going to go into standby mode. So it's waiting, it's getting ready, but maybe it's not ready completely yet. In the next line, you're seeing purge ready. So this mode indicates that all of your method parameters have been met and that they have stabilized. So once it gets to that point, it's then going to tell you on the software system, purge is ready. That does not mean that purge is getting done, right? That just means it is ready for your sample. So when you see purge ready on the software, then that means you are ready to go. You can inject one sample, you can inject 70 samples. It doesn't really matter at this point, but that machine is very happy with the settings that you have put into place and it holding those settings for an extended period of time. The next one's going to be called pressurize. Pressurize says when the Stratum PTC is connected to an Aquatech 70, which is the autosampler, this mode allows an aliquot to be removed from the sample vial and directed to a sample loop. All right, so what's going on in pressurized here? When you see that on the computer screen, they're talking about the sample vial in the autosampler. So here's the vial, there's my water solution that I'm going to be injecting, and the needle is going to come down into that vial and suck sample out. Well, it needs to suck sample out of there, and it needs to deliver it to the purge and trap concentrator, the PTC. All of this requires pressure in order to work. And if it can't pressurize itself, it's not going to do a very good job of sucking sample up, out, and into the concentrator unit. So that's what we're seeing there. All right? So pressurize when the Stratum PTC is connected to an Aquatech 70. Fill internal standard when the Stratum PTC is connected to an Aquatech 70. This mode allows the internal standard to be directed to a valve addition mechanism. So if you're using an internal standard, what it's doing is that it's allowing you to know that right now it's sucking internal standard up out of that container and it's mixing it with your sample from the vial, and then that is going into the purge and trap system eventually. Okay? The sample transfer, if that's showing up on the software, It says the Stratum PTC is connected to a liquid autosampler. This mode indicates that the sample is being introduced into the sparging vessel. So basically all that means is it's saying, listen, the pressure has been pressurized and up to par. There's no leaks. And sample now is going into that glass U-tube attachment in the front of the machine, the sparger unit. Okay? So they're letting you know that that transfer is going on. And the software will say that on the screen when it gets to that stage or that point in time. It also says the time required for this step is autosampler dependent. So you've got control of kind of how long you're going to allow it to get to the place that it needs to go before the machine is going to give you an error. The next one here is called a pre-purge. And it says when the Stratum PTC is working in conjunction with an external sample heater, this mode directs purge gas to the vessel to remove extra oxygen prior to heating and subsequent purging. This pre-purge is really only used for solid samples and not liquid samples, so we never really see this show up on our screen. This is the attachment, or the heater is what they're calling it, because that process is required for a soil sample. The preheat is also going to go along with that. It says the Stratum PTC is working in conjunction with the external sample heater, and the mode allows the sample to reach a uniform program temp prior to purge. So that preheat we're not really going to see either. Again, that's really for soil sampling. That's where we'll see more of that versus the liquid. The next one's called purge. You can kind of imagine what that one is. This mode is the VOC extraction mode. So helium is basically bubbled through your sample. The VOCs are leaving and they're getting trapped. So this is the purge step, which was one of the most important steps of the purge and trap concentrator. It says, note the gas passes through the trap, deposits the annulates, and then all of that is vented to the atmosphere. So literally helium is purging. Helium is help carrying the VOCs through the trap. The VOCs are getting trapped on the trap, but the helium is getting pumped on through, and the helium comes out of the back of the machine. The next one's called the rinse loop. It says when the Stratum PTC is connected to the Aquatech 70, this mode allows time for the sample loop to be rinsed with hot water. All right, so that rinse loop is kind of important. We talked about the cross-contamination aspect of this entire system. We said these are very low levels that we're looking for. Nothing can be contaminated, and it's going to be very easy to see contamination. So everything has to stay clean. So the rinse loop basically means that the loop your sample went into before it went into the purge and trap concentrator. Your autosampler sucking it up, it's got to keep it somewhere, and then it dumps it. Well, that is getting flushed with hot water at that point. The next one's called the purge loop. The purge loop says the PTC is connected to an Aquatech 70. This mode allows time for the sample loop to be purged with dry gas. So once it rinses, one of the problems here is that we have to make sure that there is no water contamination, right? So if we're sucking up water to flush all the lines out, then we have to make sure that this residual, because all that's going to be dumped, we have to make sure that that residual goes away. Nothing is getting carried over into the machine. And that's the purpose of this step. So what you're seeing with this step, the purge loop and the dry purge, is the gas is going through these lines and it's basically drying out everything that needs to be gone away. The dry purge, it says the mode is used to drive excess water from the analytical trap. The inert gas is directed to the trap without passing through the sample glassware. The process ensures that no additional moisture is added to the trap. All right, so the purge loop is basically going through the autosampler and getting rid of all the residual water that doesn't need to be in the places that it's in. The dry purge is basically the same thing, but it's going through the trap of the instrument. So this is just helium basically going over the trap. Any residual water that might be there is basically gone and out of the system. We do not want to transfer that over to the GC. Next one is the Desorb ready. The Desorb ready basically says the instrument is very happy now with all the processes up to this point, and it's ready to heat that trap, and it's ready to release the volatiles. And then the Desorb preheat. Well, if you want the trap to be at a certain temperature at this point, then you can tell the machine, I want this thing to be preheated. The problem, though, that you run into is that some of the lower boiling point volatiles might be driven off before it gets injected into the GC system. And you don't really want that to happen. I mean, that's the purpose of using the purge and trap, right? So you want this typically to be as low as it can go. I see very few methods out there that have this trap preheated at a certain temperature because you're losing components out of your sample. If you're going to trap them, you want to trap everything that's present. You don't want to lose or get rid of anything under normal circumstances. And then finally we get to the Desorb mode. In Desorb, that is when finally the machine is going to heat that trap up, and all of those volatile organics are going to leave the trap and make it into the GC system. So that is what we call the Desorb mode. Finally, we get to the bake stage. We see the bake fill, the bake transfer, and the bake drain. If you take a look at all three of these pieces, basically these are relating to the trap after it's delivered sample to the GC. You do not want any cross-contamination. So baking basically allows the trap to be heated up super hot. It makes sure that everything is driven off of the trap. That way you have a very clean trap for the next sample. So the bake fill, it says when it's connected to the Aquatet 70, hot water goes through that sample loop again, and it goes to the concentrator glassware, and it helps clean everything out of there. The bake transfer transfers the sample to the trap. It goes through the sparger. It begins to heat everything and begins to flush everything out of those areas. And then the bake drain. So that is the Aquatet 70 again, drains the water out of the system, and everything goes away from that point, right? So what I would do here is maybe take a look at these definitions, take a look at these terms, make sure that you can write a 1 or 2 sentence explanation about these major steps in the purge and trap system, and that way you can convey to us that you fully understand what the PTC is doing step by step by step. So if you see those on the computer screen, you now kind of know what stage of the process this is in. If you want more explanation with those, through the middle of the instruction manual, you're going to see it kind of break down the steps little bit by little bit, and they give you a little more detail about each step along the way. So, if you maybe look at that table and you're really just not happy with that 1 sentence statement that they put there, almost like a summary, then this is going to give you a chance to kind of go through, take a look at more description and more things that are happening at those stages along the way. And then maybe get a better feeling of what's going on at different stages along the course of time. It also gives you some kind of general guidelines, normal ranges that you might see. So for instance, here it says the inject. It says the inject is functional only when we're operating at those cold methods. So that's not really going to apply for us at all, so I can just kind of leave out that paragraph. And then it says bake. Bake is used to regenerate the trap and the condenser for the next turn. So all of those require temperature settings, and all of those require flow rates, because I'm going to heat this trap up to drive off all the VOCs, and then I have to rely on the helium to push out those residuals if they're staying behind. So it says, listen, if you're going to do this, it can range from 180 to 300. And then it says it's typically set between 150 to 200 for the bake. And then your flow rates can be between 5 to 500, but 3 to 4 is typically recommended for 2 to 4 minutes for a time period. So it gives you a couple of ideas about the settings. This is just general settings. Your method and your standard operating procedure are basically going to tell you what these settings need to be before you go through and start just randomly plopping numbers into the method parameters. All right, but it gives you a range and it gives you an idea of a general guideline if you're trying to make a method from scratch. Finally, what I would like to say at the end of this video is that you're going to have to go in maybe at some point in time and type in method parameters, or at least know where to find them and what they mean. You might not have to do it in our lab that we do, but maybe if you use a purge and trap system in a laboratory, you'll have to know where to key in these parameter settings. In the method development screen, this is what it looks like on the software. You're going to see a few tabs down here at the very bottom, and these are the 3 major steps that the machine goes through. So purging is basically bubbling the helium through to get rid of the VOCs. The desorb method is heating the trap up and driving off those VOCs. And then the bake tab is going to be, now that the sample's been introduced into the gas chromatograph, the bake option will help heat up that column and drive off any residual that still might be behind. And these are some of the settings that you're going to find. So under the Purge tab, you're seeing quite a bit of different settings all the way down through here that's going to be pretty important when it concerns method development. And hopefully your method or your SOP will tell you what these need to be. So everything from the transfer line to the condenser, sample heater if you have one, purging time, dry purge time, how fast the helium's going through at each one of those stages, what are the temperatures at each one of those stages, how long do you keep it at each one of those stages. All of those settings are pretty important. Under the desorb, you have less options there, but still, you're going to have to take a look at temperatures. You're going to have to take a look at how long does it desorb. Do you allow this stuff to heat up for 2 minutes? Do you allow this stuff to heat up for 10 minutes? The desorb flow. After the desorb mode, down here at the bottom, the next one's bake. So here's the bake time. So how long do you want it to heat up before the next sample gets introduced? What is the temperature? Typically, this is going to be pretty hot because you want to make sure that it's completely clean before the next one comes along. And then finally, we have the bake flow. So if there are contaminants that are behind, just the heating it up is not good enough. The helium's going to have to go through and it's going to help push them out of the machine. So how fast is that helium going to flow? All of those settings are going to be really important. Something else that I would like to say, that if you're using these types of software systems, they know that sometimes you're going to get confused on all of these different types of settings that are there. So if you just simply click on one of these line items and you go in and you key in a number, over here to the side, they're going to change the description so you know exactly what that means. So for instance, right now they're clicked on bake time and it's set at 2 minutes. Over here to the right-hand side, it's going to say choose a time long enough to eliminate the carryover between the runs. Longer times increase the purge and trap cycle time, and it decreases the throughput. So they're letting you know, listen, you want this to be enough time to clean out the trap, but the longer you put this on there, the longer it's going to take for those samples to be analyzed on the GC system. So the minimum here is 0, and the maximum is 300 minutes, basically, that you can key in. So that's what the screens are going to look like in the method development part. And these are the areas that you would have to go into if you're developing a new method. For the most part, in a laboratory, you're going to be using the same method over and over and over, and these settings will never have to be changed. They just have to be checked on a periodic basis to make sure everything's coming off like it needs to be. If you have an autosampler, you're going to see an extra tab down here at the bottom depending on which one you've got. So this one's Solitech 72. That is not the autosampler that we have. If you have the cryo unit, that's also going to be listed there as well. Those settings are going to be available to you to switch and change and modify as needed. On the Aquatech 70, which is the version that we have, here's your Autosampler table. It's pretty simple, actually. There's not a lot of columns that are there. You just need to assign the method here in the box. You click the ... choose the proper method, and then you tell it what vial that it's in. That's all that you need to do with the Autosampler on the Aquatech 70. No more than that. The GC system is the one that's going to be producing the chromatogram, producing the report, and saving your data. The only thing that the autosampler of the Purge and Trap is doing is delivering sample to the concentrator. So that's why it's not going to require anything other than vial number and then the method name. That is it. So very simple table to fill out. There's not a lot to it. That's it, folks. And finally, on the back end of this instruction manual are the troubleshooting and maintenance section that you might have to do if you're working on the Purge and Trap system. So here's a close-up of that sparger tube and the connector pieces that house it. And it's going to go through and it's going to tell you kind of some tips and tricks on what to do and how to keep this thing clean. There's actually going to be some flow charts that you saw at the end of the Autosampler instruction manual. It's going to kind of tell you kind of the order of determination, maybe ways to find out problems. Some of the questions will involve around all of that, but these are great places to start if you're having trouble on a certain aspect of the Purge and Trap system. So for instance, start the leak check, and from the diagnostic screen, place the 6-port valve into the B position. Does the unit pass the leak check? Yes or no? And then you can just use those decisions to kind of help determine what's wrong with the concentrator at that point. All right. Okay, so I think that we kind of did a rundown of the instrument. I think that maybe at this point in time you have a very good feeling of the purpose of the Purge and Trap. I think that you know what the machine looks like. I think that you maybe understand a little bit about the machine. And in the next video, I want to take a look at a method. I want to go through and look at an actual method from the EPA that talks about volatile organics and using a Purge and Trap concentrator in order to do this work. So that's what we're going to look at in maybe the next and last video of the Purge and Trap section.